Hello, welcome to part three. I want to talk now about one of the key issues which was a precursor to climate change and how it was tackled in the international community, which in some ways is perhaps now largely forgotten. But at the time, it was a hugely controversial and for many people frightening development to what was called the hole in the ozone layer. Now, the ozone layer is a natural phenomenon, part of the atmosphere containing ozone, which protects the Earth from damaging UVB light from the sun. And we've known about the existence of the ozone layer for a long time, and we were aware that it was important in protecting life and people across the planet. And what happened with the discovery of what was known as the hole in the ozone layer was that something that human beings had been doing was damaging part of the global environment so severely and so rapidly that perhaps for the first time a global environment issue became genuinely a matter of life and death. What the science came to discover was that chlorofluorocarbons, a chemical that had been developed to power aerosol sprays, air conditioning, and was in pretty well every fridge and refrigeration plant in the planet, was accumulating in the atmosphere and depleting the ozone across parts of the atmosphere. This was extremely serious because of the damage being caused would be allowing the UVB light to come and hit people, plants, the atmosphere, and cause tremendous amounts of damage. Now, as the science started to emerge, the chemical companies, who obviously made a great deal of money from manufacturing and selling CFCs, decided that the best course of action was to invest more money in lobbying politicians, Congress in the US, governments across the world, not to take action on the science, to suggest the science wasn't convincing, to suggest CFCs might not be to blame. And so, although the research was beginning to show a problem for some considerable time, it took a much longer period before we saw really serious action. So the UN convened negotiations to try and deal with CFCs and the depletion of the ozone layer back in 1981. And in 1985, 4 years later, the Vienna Convention was signed by 20 countries, but by only 20 countries. Most of the world's major industrialized powers, most of the biggest countries in the world, didn't take part. And the convention itself really only recognized that there might be a problem with the ozone layer and that action might need to be taken. It took a very dramatic development to change the course of these negotiations. And what you see hopefully on the slide here is a series of images that were taken by NASA of the level of ozone across the southern Antarctic. And this shows from 1979 onwards, when the green shows the depth of the ozone was reasonable with a small blue patch. The hole, the depletion in the ozone layer, growing dramatically through 1980 to 1984. And it was these images that featured large on the front pages of papers around the world that genuinely, I think, frightened people into demanding that the government should take action and forced the chemical companies to cooperate with the international community in tackling ozone depletion and the chemicals that were causing it. So in 1987, what was called the Montreal Protocol was agreed that set timetables for phasing out CFCs, and in the London Amendments in 1990, 3 years later, agreed much more radical steps to effectively ban CFCs and indeed to take in a ban on some of the substitutes that had been developed at an early stage because it was shown they were almost as damaging. So the industrialized countries took reasonably decisive action here to make sure that the hole in the ozone layer would start to repair. But we also had to face up to the issues of the developing countries, who also had air conditioning, fridges, aerosols, how we were going to involve them in making the same level of commitments when the costs could be quite substantial. And there were two aspects to the support for developing countries. The first was what's called technology transfer, making sure that they could access the new products, despite patent protection, on a reasonable basis, that they didn't have to pay too much for accessing the technology they needed, and supplying what was at the time a substantial sum of £240 million for developing countries of the G77 to enable them to sign up and take that action. So the Montreal Protocol, the London Amendments, the work on ozone, based on the science and research, was able to take significant steps to tackling the issue, an issue that affected everyone in terms of replacement for aerosols, coolants, and fridges. And although it's going to take considerable time, and it will actually be 2075 before the ozone layer entirely recovers to pre-1980s levels, believe it or not, images now show we are making progress. Things are on a much sounder basis. And in 2019, there was the smallest depletion, the smallest hole that had been observed since this period. So climate change came out of the evolution of international agreements on ozone, on tackling the chemicals that caused it. And indeed, I think there's no doubt that the Montreal Protocol and the agreements the international community was able to come to were a hugely important part of enabling us to tackle climate change successfully. So let's move on to the second part of the lecture, which is focused on climate change. And I wanted to just take a couple of moments to talk about the very basic science behind it. The natural greenhouse effect has been known about for a very long time. The sun emits solar radiation, which warms the planet. Some of that heat is then reflected back into the atmosphere and either escapes into space or is reflected back off the layer of greenhouse gases that sit within the atmosphere. Now that's really important, but what is a problem, as the right-hand diagram shows, is that if that layer of greenhouse gases of carbon dioxide, methane, nitrous oxide and others grows, if the layer gets thicker, more of the solar radiation that reflects back off the surface of the Earth will be trapped, and inevitably, the Earth as a whole, the planet, will see a level of warming. And that human enhanced greenhouse effect is very basic science and is not really itself in dispute. As we'll come on to talk about, there is much greater dispute about what that warming means, how fast it might occur, what the impacts should be, and how we might try to tackle the problem. That's the end of this section. Look forward to you rejoining.